Hello, hello, pre-calculus, advanced pre-calculus. Happy Monday. Here we are with our first video in my class, my first ed puzzle with you guys on arc length. Arc length, area of the sector, and distance between two cities. I actually made this video yesterday and was working on the ed puzzle today, and there was no sound. So my mic's not working, so I'm back to the headset and take two. So, arc length, recall from geometry. The arc length of a circle is the length along the circumference. All right, so what does that mean? We've got this circumference, and an arc length would just be, a section of it. It's going to be one-dimensional. It's just this little piece here for this figure. We're going to call it S for arc length. So we're going from here to here, and it's just a distance along the circumference. So it's just a fraction of the circumference. Super intuitive, super easy. All right, so arc length then is going to be some theta, so let's say it's 60 degrees, some theta out of the total, 360. So, if this were 60, that would be 1/6 of the circumference. And circumference we know is 2 pi r. Okay, so r is here, and there you go. So we are going to transfer this to radians, and we know the equivalency there from last class. This is 2 pi, theta over 2 pi. And look what happens with the 2 pi from the circumference. This radian conversion, this 2 pi, they knock each other out, and we get this lovely arc length formula, theta r. Arc length formula, theta r. Theta r, arc length. Okay, so don't confuse this with radians. This is radius. Okay, that's radius. Don't confuse the r as radians. Radian will be designated by some angle symbol, which is usually some sort of Greek letter. Often we use the letter T or theta or alpha or just some Greek letter. But that r is still standing for radius. The measure of the theta here is always in radians, so take note of that, always in radians. A couple of examples. The radian measure of a central angle is pi over 4, okay? So we like that. We like it when it's in radians. And the radius is 10 centimeters. So arc length formula is super easy here. What's my theta? Pi over 4, okay? That'd be a 45-degree angle, pi over 4. And what is my radius? 10. So we end up with 5 pi over 2, and our units are very important all the time, centimeters. Okay? Note they gave us radius, not diameter. Sometimes problems are tricky like that. Okay, find the length of an arc that subtends. There's just some language for you. Cuts off. This is going to be the same type problem, just some different language, and we're going to have to actually convert here. So 38 degrees, so just another drawing here. Radius of 5, that's indeed a radius, not a diameter. So we're good to go. Arc length is 38. Here comes that conversion factor of pi over 180. That'll get us into radians because this formula requires that we're in radians. And then our radius of 5. All right, so this all shakes down to be 38 pi times 5 over 180. When you reduce, I'm not even going to go through that to save time. It shakes out to be 19 over 18 pi. And what were we? Centimeters. So notice this is a singular dimension as we go along. It's linear in a way, if you will. If you were to flatten that out, it would be linear. So our dimensions are just to the first power. So they're just centimeters. Okay, area of a sector is next. Let's think of the area of a sector like a piece of pizza. Okay, so this is just a fraction of the area of a circle. So we're going to do the same type thing here. We're going to take this theta, some radius, and this time we're finding this space, this two-dimensional space, this area covered. And so the area of the sector is going to be some fraction out of 360. And then our area formula. So pi r squared is our area formula. This was our circumference formula, 2 pi r. Here's our area formula. And let's do our conversion to radians. That 2 pi, make that conversion. And the pi's cancel. Okay, and so we're going to write this one. We're going to put this 1/2 out in front and do theta r squared. 1/2 theta r squared is how you're going to find the area of a sector. This is in radians. Note that, star that, always be in radians. All right, so some example problems for us. The first one, find the area of the sector formed by a central angle of 2/3 radians. There's an example of a radian measure where you don't have the pi involved, and that's fine. Usually pi will be there and indicate radians, but it doesn't have to. The main thing that you'll see is a degree symbol. If you don't see a degree symbol, assume it's radians, even if you don't see a pi there, or even if it doesn't mention radians. All right, so just, not to scale, I'm just putting 2/3 there as the central angle, radius of 6 feet. They've yet to try to trick me with the diameter, but just note that's out there. Oh, there we go, diameter. And this is area. So 1/2 central angle of 2/3 and r squared. So compute, and this comes out to 12 square feet. Okay, so get your units right. With area, your units are squared. All right, the area of the sector is 9 square meters, and the central angle is 150 degrees. Find the diameter of the circle. So it's always a good plan to read first and just don't attack the problem. Just think about it. All right, they've given me now the area. They've given me the area. The 1/2 is the 1/2. The central angle is 150. It's going to require the conversion. We're going to solve it out for r squared. I'll take that square root, and then it says diameter here, so I'm going to want to double it. So now I have a little plan in my head to move forward. All right, so 9 equals 1/2 150 times pi over 180, and then r squared. So just a little simplification here. Let's see, this will be 5 pi over 6 r squared, so that's going to be 12. 12 will multiply up over here to 108. We'll divide out by this 5 pi, just some basic solving there, and we get r squared. Okay, so again, 2 times 6 is 12. Cross multiply it over, that's 108, divided by 5 pi. And square root theorem, square root, plus or minus, but we just need the plus. And this will be, with your calculator, punch. You end up getting 2.622 for your radius. I want to double that for your diameter, of course. And go to your units. And we're meters. And we are meters. Meter square was given, but diameter would be in meters. All right. Next little problem here, and then we'll move on to the distance between two cities. This is very common. The clock is moving, the minute hand or the second hand or what have you is moving, so you got to kind of think about these problems. So we've got to figure out what theta is. Theta is you get degrees, great. You get radians, great. Well, they didn't give us that here, so you could sort of figure it out if you'd like to. A lot of different options. And I don't really care which way you go about it. I mean, you could think about 30 seconds in terms of degrees. Each minute, there's 60 minutes in rotation of 360. So each minute is like 6 degrees. So 30 seconds would be 3 degrees out of 360, which would be 1 over 20, 2 pi r. You could do something like that if you were going back to geometry. But we're going to try to just talk about it more in pre-calculus terms here. All right. So this is arc length. The minute hand. The minute hand goes around the clock. It does 1 revolution. I'm going the wrong way. I'm looking at its reflected, so I'm going the wrong way. 1 revolution in 60 minutes. Okay, so that's not. We got to make that into theta into radians. So 1 revolution in 60 minutes is what I have. And so you kind of have to use a little dimensional analysis here to figure this out. 1 revolution in 60 minutes. All right, so how far did I go here? Well, I went half a minute. Okay, And, what is a revolution? A revolution is 2 pi. So I want to get the revolution to cancel out. So I'm going to multiply by 2 pi, and that's 1 revolution. All right, so this is your theta. So you can see here how we got that 1 over 120, which I spoke to earlier. If you were doing 3 degrees out of 360, that's 1 out of 120 there. And then you've got that 2 pi. This is the theta, but if you thought about it as 1 over 120, then you're going to get your 2 pi, and then your r here is going to be 9. So they kind of just, they're all one and the same, just different ways of thinking about it. Anyway, so let's see. Those cancel. Right, those cancel. Looks like I'm going to end up with 3 pi over 20 minutes, revolutions. Radians aren't really a unit per se, so they don't factor into dimensional analysis. So you don't have to write radians there. They're unitless, if you will. Radians are unitless, so they don't factor into needing to be canceled in dimensional analysis. Revolutions do, but radians do not. All right, so there we are, and these are what, inches? Okay, so there's the first one. So that was A. Here's B. Okay, so this will be easier since we've kind of got the hang of it. And so again, we've got 1 revolution in 60 minutes. How long did we go? 2 minutes. Well, 1 revolution is 2 pi. That's my theta. And we have our same radius. Okay, so this one comes out to be, this one shakes out to be 3 pi over 5. Okay, and then the last one, C, we'll squish it down here. So we can kind of see what's going on here. So 5 hours, that's going to be 5 revolutions. Okay, so 5 revolutions there. It's going to be multiplied by our 2 pi, and then our radius. So this one comes out to be 90 pi inches. All right, so that would be 1 revolution per 60 minutes times 5. You could 5 hours, so you could pull all of that into kind of do it here, and you'd end up just getting the times 5. 5 times 2 pi times 9. Okay, let's move on to distance between 2 cities. All right, so any location on Earth can be described by 2 numbers, kind of a horizontal and a vertical. So latitude and longitude. Okay, and so we're going to be looking for the distance between 2 cities. And so if we have a city, this city here, P, say this point P, then it's got some DMS measure. So some DMS measure means, like we talked about before, 35 degrees, 43 minutes, 9 seconds. Don't confuse this with, feet and inches. All right, so a degree is 60 minutes, and then 60 seconds, and then, all of this is all just kind of application talk. We've already discussed all of this. So imagine the Earth is a transparent sphere, and through the transparent Earth drawing, we can see the equatorial plane, and the middle point 0 is the origin. So we're focusing here, origin. And to specify the latitude at some point on the surface, draw the radius to that point, okay? So there we go. There's the horizontal. We're just going to that point. And this is kind of like the equator right here. It's going to the side right through that center. So there's going to be an angle from the equator, that center, up to point P. And so this is going to be north, right? This is going to be north. There will be some angle of elevation there. The angle of elevation of that point, if it's above the equator, this is north. My pen's running out. That's north. And if you do some point P down here, that's going to be below, and that's going to be south. So that's going to be important to note if you're north or south. All right. So if we're trying to find the difference between the two cities, really you can take the top city and minus the bottom city. So you can, if you can always do P, P sub 2 minus P sub 1. That's how you find distance, you subtract. So this is going to read a little confusing because this doesn't really have the math in it. But you can always do P2 minus P1. So if they're both north, if they're on the same side of the equator, so say they're both north, you're just going to subtract, the two northern, and you're going to get the distance between those 2 points. But once you cross the equator, this is technically a negative angle. So because it went below. And so this is technically a negative angle. So you would be saying 0.2 minus a negative 0.1. So you're actually adding the two. So this gives you kind of a little shortcut there. It's not really math, but it gives you the shortcut. If the two cities are on the same side of the equation, both north or both south, you're going to just do the difference. But if they're on the opposite, if one's north and one's south, you're going to end up adding those two up because you're going to be minusing off a negative angle. So add. All right. So here we go. San Antonio, Texas is north. Mexico City, Mexico is also north. So we are going to just get the distance. So for distance, that is going to be an arc length. Okay, I gave you a little hint right here. All right, so here we go. Arc length. Theta here is going to be 29.5 minus 20. They're both north, so the difference between those is 9.5 degrees. And then our radius, it tells us that we're going to be using 4,000 miles. All right, and so we're going to need to do our conversion factor. So n will come pi over 180, and we'll put in the 4,000. Just our arc length. Okay, and so that is going to be 663.225 miles. Easy. All right, the next one, we are south and north. Okay, so I'm going to just kind of put this on the diagram here so you can see. So if this were 30 degrees north and this were 15 degrees south, you can see why you would add those together for 45. So if they're different directions, you add them. But basically, you're doing 30 minus negative 15, which is 45. Either way you want to think about it. So here we go. That is 45 times pi over 180 times 4,000. All right? And so that one is going to shake out to be 3,141.593 miles. All right, last one. You're going to need to convert these. So let's do that. Just to remind you how to do that, I would go in here and just real quick, let's do 25 second angle degree, 40 second angle, 2 is your minute, and then 37 alpha second. And I should have done, this was the bigger angle, so I should have done this one first. I'm just going to back up and insert. Sorry about that. Right here, I'm going to do 42 angle degree. And then I'm going to do 7 second apse, which is your angle, 2, which is your minute. And then I'm going to do 15 alpha plus, which is your second, and then minus those. Okay, so hopefully I have that right. Let's see. 42, 7, 15, minus 25, 46. I need to change that. 37. So always check. Here I go. Let's fix that. 46, and enter. So there is your theta. So when all is said and done here, when you do Erie minus Miami on the TI, we got our theta is 16.3439. I'll write that. Okay, but I would just keep that in the calculator, honestly. I would just keep that in the calculator, and let's just do our calculations here. The more numbers you keep, the safer you're going to be. But basically, we're going to be doing that 16.34388, 8, so on and so forth. We'll just stop it there. Times pi over 180 times our 4,000. All right, so let's see what we got. I'm just going to say times, plus times, whoops, let's go back, times, I lost it all. Let's see. Enter, got it back. All right, so I'm going to do times, where am I? Pi times 4,000 divided by 180. All right, and so this is 1141.019 miles. Distance between Miami and Erie. All right, my friends, that's a wrap on our distance between two cities, arc length, and area of a sector. I look forward to seeing you guys tomorrow in class or online, and have a great rest of your Monday. See ya.